Hello, welcome. Today we're going to be discussing the exercise number 121 of Leetcode, or the best time to buy and sell a stock. Now, let's see here in the problem description. So, if you remember, we want to know first what are the inputs. We want to make note first what are the inputs, outputs, and constraints. The input is an array of prices. The output is a single integer that denotes the maximum profit that I was allowed to trade. Now, if we go to a store and we buy an item let's say that we buy today an item for $7 here. But then tomorrow, I can sell it for only $1. Now, that's not a good investment, is it? Because I'll be effectively losing $6. But let's say that I buy the item tomorrow and then I sell that item on, say, next week. And I was able to sell it for $6. Now, that is a good investment because I was able to get a profit of $5. So that is our constraint. Our constraint is denoted that we cannot go back in time. Meaning that if we make a trade today, we just have to sell it other day. We cannot go, let's say, make a trade next week and trade it a week ago. Okay, so this is like time. Time doesn't go back. So that is our constraint. So having said that, and having worked on this problem, we see that our maximum profit is only $5 for this problem. Now, let's work on this example number 2. So we go here, 7, 6, 4, 3, 1. I want you to know that the input array doesn't have a specific increasing pattern or decreasing pattern. In this case, it just turned out to be in a decreasing pattern. That means that any day we try to buy something, we'll be at a loss for every single day. So in this case, when our profit goes into the negative, we return 0. Having understood the problem, now let's work on a pattern. Let's work on a strategy to solve this problem. Our first strategy is the brute force approach. Let's take back our 7, 1, 5, 3, 6, 4. Let's take back our array of 7, 1, 6, 3, 4. Let's imagine that we only have one pointer. Our pointer is the present day. So I need to analyze buying and selling that same item for every available day I'm able to trade. And then I have to store in a variable the maximum profit I can get. So in this case, I have max profit. Let's say that this profit is very negative in the infinite. Okay, and then we start with our first for loop of num I. that's gonna denote our 7. So in order to make the comparison with 7 and every other day of trade, I need to have another for loop. Okay. And here we analyze, hey, what is bigger? So we say profit equals of num j minus num I. So we have the profit of num j minus num I. So it will be 7 minus 1 for the first day will be a profit of 6. Well, a loss of 6. This is a loss. Seven and 6 is gonna be 5. 7 and 3 is gonna be 4. So in order to denote a good loss, we have to actually change these numbers around. So we have to say 1 minus 7 to actually denote with the sign of this number that is a loss. So I'm going to turn this around. Okay, so let's crush this. Profit num of I. Actually, I had it right. Num j. I just did the math wrong here in the side. Okay, num j minus num I, because num j is 1. 1 minus 7 equals -6. I just did the math here wrong. So what we're missing in our algorithm is the final comparison if profit is more than max profit. We're going to replace max profit with profit. When we complete our routine, remember we cannot return negative numbers. So if max profit is less than 0, we return 0, else we return the value of max profit. So this is our, so I haven't confused you. So this is our pseudocode for our algorithm in brute force. So we can code this up and we are going to have a time complexity of big O of n squared. Now, in terms of getting this working, this, again, it's gonna work, but it's not what we're looking for. What we're looking for is for the best solution. So let's analyze if we can get this working on a single pass. A single pass meaning just one loop. So in this case, in the one pass solution, we have to keep track of two variables in a single pass. The first variable we have to keep track of is the minimum selling price. Let's imagine this is a very large number, the maximum of the integers. Let's imagine that is our initializing value. Then we have to keep track of the maximum profit. And the maximum profit at the beginning is going to be 0. So let's start our for loop of I until num's length. Okay, we have to keep track of the things at a single time. First, if we're only seeing the 7 at a time, or we're seeing every day at a time, which we have to analyze if that's the lower selling price we have available. in the first iteration for the first day, we see that 7 is less than the infinite maximum integer. So that's going to be our first comparison. If num of I, meaning the present item we are seeing in our pointer, is that number less than our minimum selling price? If yes, then that means we have to replace this value for our current minimum price. So at the beginning it's gonna be 7, but eventually in the next iteration you see there's gonna be 1 because 1 is less than 7. So we say profit. Now we need another comparison. The comparison is the problem, the problem we are solving, right? So the other comparison is, okay, so am I able to make a trade, and is that trade allowing me to have a positive return? So the other comparison is gonna be, okay, so if I sell, let's say that we are in the second iteration. This pointer has moved here. Our profit has now value of 1. Okay. And yeah, let's say that we move here also. So if nums of I, let's see. Actually, I made an error here. We are replacing minimum selling price. So let's delete this. Yeah. Now let's say that we are trying to sell at this value. So that will be nums of I minus minimum selling price. If the present day allows me to have a positive return by subtracting 6 minus the minimum selling price of 1, remember here we are keeping track of the lower number we're able to buy. If we bought in the previous iteration the stock at a price of 1 and then the next day we have a selling price of 6, that means that 6 minus 1 equals 5, and 5 is bigger than 0. So that means that in this iteration, when we have the pointer pointing to number 6, we have a positive return. So in this case, we have to update this variable, the max profit variable. So we have to put this variable with a value of the current price minus the minimum selling price. Remember that when the pointer is at this index of 0, 1, and 2, when the pointer is at index 2, meaning I equals 2, nums of I equals 6, but the selling price was 1. So we have 6 minus 1. We have a return, or like a return of 5. So we are going to update this information here. At the end of the iteration, we have analyzed all the numbers, all the trading days, and we have to return max profit. The difference of this approach and the brute force approach is that because we are initializing max profit to be a value of 0, we don't have to make the comparison for when our return is negative, because we are also keeping track of the minimum selling price and the maximum profit at a single pass. So in here we only have one iteration, so this allows us to have a big O complexity of n. Now let's code this solution up in Java. Let's start by declaring the variables minimum selling price and max profit. Following, we're going to declare our for loop. In here, we're inside the for loop, we're going to have two comparisons. The first comparison is to get the minimum selling price. And the second comparison is to get the max profit. Finally, we return the max profit. Thank you for watching. Again, the notes are available in PDF format in the description box. And if you have any advice, feedback, or comments, please leave them in the comment section below. Thank you, and until next time.